Welcome back to this lecture. This is in continuation of the Fourier series that we discussed in my previous video lecture. In that, let me revise what I discussed is that x of t is any signal that can be represented in the sum of a constant, which is also called the DC term, and an infinite series of cos term and an infinite series of sine term. Okay. Now, what is generally needed is we have to find this coefficients. Okay, a naught, an, or a1, a2, a3, so on, b1, b2, b3. So what we are generally asked in the questions in GATE exam is the value of these coefficients. Okay, so how to find that? A naught is simply a constant, so I have to integrate x of t, right? And an, that are these terms with the cos, so here I have to multiply xt with the cos nt term. Okay, where n we can change accordingly whatever is asked in the question. Suppose a2 is asked, we will put n as 2, a4 is asked, I will put 4, a3 is asked, I will put 3. Okay, similarly for sine, that is bn. Okay, so x of t, sine t, dt. So this is all that I told in previous class, and here I will solve some questions, okay, that were asked in GATE. And one important trick or concept that I want to tell you in this lecture is that, so remember, my f of x has a DC term, some cos terms, right, some sine terms. This is what I have, right? This is my Fourier series expansion. Fine. Now, if this function is even, okay, if it is even, then I will only have a naught and an terms, but bn terms I won't have. Okay, if I have an odd function as f of x, then I will not have a naught, I will not have an, I will only have bn. Why so? Why this is so? Because whenever it is even, constant would be there. Okay, because this is raised to power 0, that is 1. And cos is a even function. Okay, remember I told in one of my video lectures what is even function, what is odd. If you don't recall it, just go through that video lecture and you will understand. Okay, here also I'm explaining in brief. So what does my cos function look like? This is my cos function, right? Because it is 1 at 0. Okay, this is cos function. What is sine function? It is 0 at this point. At pi by 2, it has a maximum value, and like this. I'm not able to make it symmetrical, but it is symmetrical, right? So this is my sine function. This is my cos function. Okay, so it is at origin, it is symmetrical. If I fold it across this axis, across this y-axis, if I fold it, it will be symmetrical on both the sides. Okay, this is an infinite cos signal, and when I fold it with respect to this y-axis, it will be same. That means it is a even function. Okay, one more way to check is f of x is equal to f of minus x. So cos of minus x is cos of x, you already know. That means this is an even signal. When I talk of sine, it is not symmetrical across this y-axis. So can you fold it and check? So when I fold it, so suppose this is my right hand side. When I fold it, okay, so this becomes, folding means I have to just make a mirror image. So when I make a mirror image, it looks like this. Are these two same? No. That means sine is a odd function. Okay, one more way to check is f of x is equal to minus f of minus x. Okay, so for sine of minus x, it is minus sine x. Hence this is odd. So this is my even, this is even, but this is odd. Okay, so whenever odd is there, only these sine terms would be present. Whenever it is even, these two terms would be there, but this term would be absent. Okay, so this is, you need not remember it, you just remember the concept. What is even, what is odd? You will remember that in even these two should be there, this shouldn't be there. In odd, this should be there, these both terms should not be there. So in GATE back to back, it's like 2-3 years continuously they have asked such kind of questions, which just requires this much knowledge. Okay, so I'm exactly writing what the question was. So it was asked in 1996 and 2011 in GATE. Fourier series, I am writing FS in short, of even function does not have, okay, this was the question. Now options are DC term, this was the first option. Next option was sine, third option was cosine, last option was odd harmonics. Okay, now even function, okay, so even should have a naught an, and bn should be absent. What it is asking, remember, does not have. It is not asking what it has, it is asking what it does not have. So it will not have bn. Bn means it will not have sine terms. Okay, so it's not going to have sine terms. Very easy, very easy 1 mark question. Directly you can get no chance of getting it wrong. Okay, now you must be wondering what other options are. So DC term I already told, that is a naught here, and a naught will be only when it is even, right? And it is telling does not. Okay, if it asks even function has DC term and cos, right? And cos you know, sine you know. What is odd harmonics? Odd harmonics does not mean odd. Okay, that only means whatever terms are there, suppose cos or sine, it will have only cos x, cos 3x, cos 5x, cos 7x. Cos would be there because it's an even function, but the terms, this should be 1 3 5 odd numbers. Okay, but that doesn't make the function to be odd. Okay, because this is cos of anything would be even. Okay, and what would be the even harmonics in that case? It would be cos 2x, cos 4x, cos 6x. So what harmonic actually mean is that, okay, let me tell you what harmonic actually means. So I told you there is a fundamental, the first one, this cos x, this is the fundamental. Okay, fundamental means there is no multiplication anything, it's x, only x. Okay, this is the normal one. When I write cos 2x, it is called harmonic. This is called second harmonic. Okay, because there is a 2 multiplication factor involved here. So this will have the same shape, but it will be a kind of, because this is like cos 2x, it will be kind of compressed by factor of 2. Okay, so these are actually called harmonics. This is the main one, that is called fundamental, and these all would be harmonics. When I say even harmonics, then it means cos 2x, cos 4x, sine 2x, sine 4x, like that. Remember, even harmonics, I'm not saying even function. Okay, remember, the silly mistake that people can do here is that do not confuse even with even harmonics. Even harmonics means whatever function you have, the inside terms would be even. Okay, what odd harmonics would mean, what our odd harmonics would mean is that cos x, cos 3x, cos 5x, it can be sine x, sine 7x, it can be sine 19x, but the thing is all these terms are odd. All these inside terms are odd. Okay, odd factors, you can say odd multiplication factor, but this is not odd. While even would be what? Cos term, any term, cos x, cos 2x, blah blah blah, cos 10x, or even cos 3x. Okay, this is also even, this is also even, everything cos is there, so it is even. Remember, when I say sine, like sine x, sine 2x, sine 3x, whatever, then it is an odd function. Okay, however, if I say even harmonics, this is even harmonics, this is even harmonics, this is also even harmonics. But when I say even function, then it is cos, sine, odd function. So I think you are clear with what is harmonic, what is even harmonic, what is odd harmonic, what are even and odd functions. That's all you need to know, nothing more than that. Okay, and these questions will be just like this. Okay, so let me do one more question. This was asked in 1998, so it's very old and it's kind of tricky, not difficult, but yeah, it might seem to be tough. So question is, periodic signal is given. Okay, now remember one thing, they have mentioned in the question itself that the signal is periodic, so there is no chance that the Fourier series does not exist. Now you know, right, that whenever I have a signal periodic, Fourier series is guaranteed. Okay, so x of t and of period is t naught. That is also mentioned in the question. Okay, now xt given to me as 1 0 mod t less than t1, t1 less than mod t less than t naught by 2. Okay, this is given to me. What is asked is find the dc component of xt. The options given are t1 by t naught, 2 t1 by t naught, t1 by 2 t naught, and t naught by t1. Step by step we'll do, and we'll solve will within very few time. Okay, within very fraction of seconds we can do it. Not fraction of seconds, at least fraction of minutes we can do. So first thing, quickly we need to do what I need to find in this. A naught. We know this is only thing DC, right? A naught is the easiest thing to find. What's the definition? 1 by t x of t dt, right? Now what is t? T is my time period, that is given to be t naught. Okay, so let me put A naught is 1 by t naught. Okay, x of t is what? I have to write. The only thing I need to see is what is my interval. Okay, this interval. How to find what is the interval? Okay, so okay, so see carefully. Mod t less than t1. This is what it is given in the question. Okay, for this the value is 1. Okay, for the rest the value is 0. So what this means is mod t, we know mod function, I told in one video lecture that it is having plus and minus. So plus t less than 1, minus t less than t1. This means t less than t1, this means t greater than minus t1, right? So if I consider this point to be minus t1, this point to be t1, then t is greater than minus t1, okay, and t is less than t1, okay. So this is my range, okay, this is the range. So t is lying between minus t1 to t1. See, t is lying between, it is greater than minus t1, yeah, it is less than t1, okay. So this is my range. So I got my interval. What my interval would be? Minus t1 to t1. And what would be the value? This value is 1. So xt is 1. So this is the thing. And rest all it is 0. Doesn't matter because 0 multiplied by anything is 0. So this is my answer. So it is only t and pi plus pi. Okay, this is 2 pi, fine, but there is a t naught here, right? This is what we have done, xt dt, right? So divided by t naught. Okay, so I have, oh sorry, this is not pi, this is t1, sorry, my writing. So this is t1 plus t1, so this is 2t1 by t naught. So my answer is 2t1 by t naught. This is the answer. So it matches with B. It was easy, right? So what I did, I will tell you very quickly. First thing I saw in the question was, okay, my time period is t naught. Fine. This is periodic. Okay, I can find Fourier series. It is asking for DC term. Okay, I need to find only A naught. Right? This is what I need to find. Okay, what is the definition of A naught? This is fine. Now t is t naught. Okay, I put t as t naught. This is also fine. Now this integral I have to solve. Okay, this is t. Now what is time period? Okay, that is what I have to check from here. So this is the zero value of the signal, that doesn't matter because xt would be 0, right? 0 into dt 0. So only thing is this is what is matter. Okay, so I took this interval mod t less than t1. So mod t less than t1, it breaks up into this thing, t less than t1 minus t less than t1. So I get this. I got minus t1 to t1 my interval. So my limits would be minus t1 to t1, right? And the value is 1. The value of xt is 1. So this becomes 1 by t naught, right? 1 by t naught. And this is minus t1 to t1, 1 into dt, right? So this becomes 2t1 by t naught. Okay. So this was a kind of the most difficult question ever asked in this topic. So you can consider if you could do this question without my help. That means you have understood the Fourier series very well for engineering mathematics gate examination. Okay. because in electrical domain and electronics it will be even further kind of questions, deep questions would be asked, because this is a topic also involved in signals and systems. Okay, but in terms of engineering mathematics, this is the only thing that you need to know. Okay, so you know even harmonics, odd harmonics, even function, odd function, what is the Fourier series. Okay, and Fourier series, how to find the coefficients for each of the term, this you need to understand. It will ask either for a1, a2, a3, so on, b1, b2, b3, so on, or the dc term. This is called dc term, or the constant. And if it is asking for constant, it's the easiest question, as it was in this question. Or it may ask the questions like this, as in 1996 and 2011. It will only ask it is even function or odd function and what it will have. So you just need to remember this thing. Okay, and that too, you need not fix it in your mind. You just remember what is even, what is odd, and accordingly you can easily do it. Okay, so I hope you have understood it fully and you have enjoyed my video. Please share and subscribe if you like my videos, and keep watching. Thank you so much.